Chapter 3 is back to core 1 and core 2. Okay, you're going to be integrating, you're going to be drawing graphs, okay? And the what it's all about is about one of these things, which you've always known as the normal distribution. But we never told you the algebra for that. No offense, it was because you can't handle the algebra for that. Okay, I'll tell you what it is if you want. Nothing you're learning with Miss Pearson will tell you how to integrate that. It's just too hard. That's the algebra for that. Okay? It's also pesky because it goes out forever. Now, nothing in your integration is skills in core 4 is telling you how to handle terminals of infinity and negative infinity. Okay? So 3a and 3b and so on is just a nice user-friendly version of this. Okay? Now this thing is called a PDF. It stands for probability, density, function, and how high it is, who cares? At no point did we ever ask you how high the normal distribution graph was. What matters is areas, because the areas give you probabilities. Okay? Which means this whole thing is only for continuous distributions. In other words, distributions where you're interested in between values. Remember how I told you for the normal, the probability of that is just 0? Why is the probability of getting 3 0? Because there's so many other billions of numbers that it could be other than 3. It could be 3.01, 2.999999999. So the chances that your height or whatever is actually 3, just no number is low enough to express it, so we just give up and say that it's 0. That makes sense because under any graph, the area between 3 and 3 is 0. Okay? So that's why this whole chapter is just for continuous distributions. And the binomial, remember, is a discrete distribution where there aren't billions of numbers it can be. There's just like 5, 7, 6, etc. Same on. And that's why when we wanted to use the normal as an approximation to the binomial or the Poisson, we had to do a trick, because if we wanted to work out that you get exactly 5 flowers, the normal will give you 0. So we tricked it into doing an area, so that we could at least get a sensible answer. Okay? So that's why I say these things are all about areas. Okay? So, I told you that this was going to be a user-friendly version of this. In other words, it's going to be ones of these where we can give you the algebra and we can expect you to do integration, yeah, rather than just look stuff up in a table. Now, if we're going to make it user-friendly for you, we have to have some ground rules. The first ground rule is what's called the look. Okay? The look is this. Always a lowercase f. Okay? Always a 0 followed by the word otherwise. Then we're going to have some algebra. And it has to tell you when that algebra applies. Okay? So that's the classic look. If you cannot see 0 otherwise, it's not a fair PDF for stage 2. Okay? Now, can I just ask you, don't you think it's a bit sloppy? Why is that a bit sloppy?
Because you don't know where 3 goes.
You don't know which rule to use if it's number 3. Who cares? Why do I not care? Because you're never interested in just particular values. You don't substitute into this. You don't substitute into it to say, oh, look, I got 7, that's the answer to something. You only work out areas between stuff. And therefore, it doesn't matter whether I rub that out. It'll make no difference anyway. Because the extra area you get by adding a 3 on is infinitesimally low. Okay? But anyway, in general, they will try to be nice to you and they will try to give you mutually exclusive categories there. But I'm saying if they don't, it doesn't matter. Okay? So that's the look. Now this raises the question, is anything that looks like that a PDF? And the answer is no. So does anything that meets the look, is anything that meets the look a PDF? And the answer is no. You need to do a couple of checks. First is the look. Okay? The second check is area under graph equal to 1? If the area under the graph is not equal to 1, it's not a PDF. How do you check if the area is under the graph is equal to 1? You can use Core 2 integration. You can also use Year 7 formulas. If you can tell that something is just a triangle, use half base times half. Okay? So that's the second check. Third check, does it cross, and I mean cross, not touch, the x-axis? If I give you something, okay, the fact that I'm setting that up means that it's 0 otherwise, okay? This has a chance of being a PDF because it makes sense to me is that area under those could be probabilities. This is ridiculous. Why is that ridiculous? Remember, areas under this thing are supposed to give you probabilities, just like that. If you're doing integration, you're supposed to get a probability. So why is that ridiculous? Anyone? What's the difference between this and this? They've both got these bits where there's 0 out to the left and out to the right. I haven't given you any scales, so they could easily have areas of 1 under them.
One goes further than the other.
One crosses the axis. Yeah, and why is that ridiculous? Because this would give you negative areas.
So if it crosses the x-axis, it's not.
It cannot be a well-designed algebra that would give you probability answers because you cannot get negative answers to probabilities. You cool? So that leads in 3A to some classic little questions. Okay? Now can you just have a look? Just have a scan down 3A. Tell me all the different types of questions they've got. Question 1. They ask you to say why they cannot possibly be probability density functions. It's multiple choice out of 3. Either it doesn't meet the look, the area is not 1, or it crosses the x-axis. Okay? Question number 2. In question number 2, they tell you that something's a probability density function and they expect you to work out the k. I'll give you an example like that. So this fella, this meets the look. Okay, now let's get a bit of a graph going. Kicks in at 3, kicks out at 5, it's 0 to the left, 0 to the right. It's just a straight line in between. If you put a 3 in there, what do you get? You get k. I can assume that k is positive or else you'll have a graph underneath the x-axis. If I put a 5 in, I get 3k. So, it certainly meets the look. It certainly doesn't cross the x-axis. Is the area under this 1? Well, it can be if k is right. Okay, so we can integrate it. That's very simple. Extremely simple if you use mathmosis. Just move the k out. And apparently that fella is 4. So k would be equal to a quarter if you want it to be a PDF. You cool with that? What other things do they have in 3A?
How did you get 4?
I just skipped it. That's just a core 2 question.
I know, but I didn't get that.
Oh, didn't you? You worked fast.
I'm trying to do it myself, and I like kind of
Okay, yeah,
know.
let's do it. You good?
How did you do it on pass?
So, half of 25 minus 10 minus half of 9
Okay.
minus 6. So what's that? That's 2.5. That's 12.5 minus 10.
Yeah.
There we go. That's what it's for.
And then
You cool? A few minutes using trapezium, girls. How do you work out the area of a trapezium? It's half
half
Base.
the gap between the parallel sides times the sum of sides. Gee, this came out way fast. Hold on.
Can you go down, please?
That's k. That's 3k. So this way. Oh, yeah, there we go. That's 4k. If you want the area to be 1, it needs to be k equals a quarter. Okay. What else have we got? We've got ones we have to sketch it. Straight lines and so on. Now, is anyone freaked out by having to graph something when there's a k there? Just make up a value. Right? Pretend it's a 1. Just pretend it's a that. An example problem smaller and simpler by taking.
Declare and like.
Oh, the phrase of the question is, if it's PF, what must it be? It's a pathetic question.
But like, how can you when it doesn't equal 1?
I made it equal.
4k equal.
That is the one. Yes, it does. If k is a quarter.
You're saying that x is 1. You're just saying that.
Yes, that's right.
Okay.
Sometimes they say it be a PF must k. Sometimes it is a PF k. And so if you enter here, triangles and trapezium. Okay? And that's all. Okay? So just mark on the graphs where the graphs need to be pretty special. They're going to be a PF. Are there any questions about that?